So the last video I did, I talked about sprag clutch and investigating that as a possible solution for disengaging the winding wheel from the transfer shaft. Okay. So after the weight falls, just to kind of go over something real quick from the last video. After the weight falls here on this gravity driven generator and the shaft is no longer rotating and transferring, of course, the motion to the gearbox and to the PMA back there to generate electricity. After the whole process is stopped, right, and the weight is fallen, well, the weight has to be wound back up, which I mentioned already is going to be done manually through a boat winch, which is right there. Okay. Now, the problem is when you wind the weight back up, when a chain is attached to the sprocket, which is not mounted on here right now, but when a sprocket's mounted on here, we would be competing with the force of the gearbox, a high ratio gearbox. That's not going to work. It's going to be very difficult to bring the weight back up. Okay? So there has to be a way to disengage the transfer shaft when we're winding the weight back up. Okay? So that gets us back to where I was last time in the video, where we talked about using one of these, which is called a sprag clutch, specifically a backstopping sprag clutch, so that we could actually facilitate disengaging the weight from the winding of the weight back up from the transfer shaft. Okay. So I looked into these and been poking around on eBay and some other sites, and for the amount of torque that I need for this application, these are very expensive. Even the ones that are sitting in old stock and so on and so forth. I'll keep looking around, but they're very expensive. These things run well over $1,000. Some of them even more than that. I've seen some of these run up into over $10,000. For the one I need, at least brand new, it's well over $1,000. Okay, I just can't justify spending that kind of money. I'll keep looking into some sprag clutches, backstopping clutches, to see. It's actually a freewheel backstop combination kind of clutch, but I'll keep looking to see if I find something. But anyway, I've been throwing around some other idea, and some of you are going to recognize this, especially you automotive guys. And this is a typical assembly for a manual transmission. Now, this particular picture you're seeing here only shows the meshing of two gears. The one on the far right, this is a gear, and the one on the far left, this is a gear. Okay? And everything in between is part of a synchronizing process or synchronizing components that help mesh these two gears together. Okay? So I've been looking into the idea of tinkering around with this. And just to quickly go through some of the components, this is a gear. Let me get my glasses on, sorry. Can't see what I'm doing here. This is what's called a blocking ring. This is what's known as a synchronizing hub or synchronizer hub. This piece in the middle is known as a shift, or a sleeve or a shift sleeve. I just call it a sleeve. And then from to the right, we're just repeating the process, right? This is once again known as a blocking ring, and this right here is known as a synchronizing cone, and then another gear. So way back over here, this little component right here is also a synchronizing cone, this little piece right here. Okay. Now, I've taken a close look at this assembly. I've looked at some YouTube videos. I've watched how it's actuated, and I'm pretty certain that for this application, all I'm going to need is the sleeve, and what I'm going to do is I'm going to take a synchronizing hub or at least something similar to that, and attach it straight to, instead of a gear, to the sprocket face, okay? So I won't be using this synchronizing cone, which has teeth of its own, okay? But I don't need that. And the reason I don't need that is because I'm not going to be synchronizing two sprockets while they're both moving, okay? So that's called unsynchronized meshing. And that's common when you're trying to get your car into first gear or put your car in reverse on a manual transmission. Those are what we call non-synchronized or unsynchronized gear meshing. For any of you out there that drive manual transmission, I'm sure you've heard it a million times. You're trying to get the car in first gear and you're fighting the gearbox, and sometimes it makes a little grinding noise. Same thing in reverse, you kind of feel a little clunky engagement. That's because they're not synchronized, okay? And that's only possible when both, in this case, sprockets on each end are not moving. Okay, so I'm not going to need a synchronizing cone. I'm not going to need a blocking ring, but I am going to need some form of synchronizer hub, or, yeah, synchronizer hub, which there's going to be two of these. I'm going to attach them straight to the sprocket on the end. So this will attach straight to this without this piece in the middle and without the cone. And I'll do the same thing on the other side. And then I'll have a nice big fat wide sleeve. So the way this works is when the sleeve is all the way over to one gear, or in my case all the way over to one sprocket, the two sprockets or the two gears will not be synchronized, meaning they will not spin together. The one will just be sitting idle while the other one turns. Okay. When I want to synchronize them, I'm simply going to take the sleeve and move it halfway off of the hound dog next door is going crazy because the ambulance's siren's going off. Yeah, I love these hound dogs. Hilarious. So, yeah, hound dogs and ambulances, they just don't go together. Pretty funny, right? A little Texas humor here. So, the sleeve, when it's halfway off of the synchronizing hub, will actually be synchronizing the two gears, the two sprockets together, okay? I won't get into all the details, but you can Google that, check it out yourself to see how a manual transmission works with the sleeve and the synchronizing hub. But I'm pretty sure that I could probably fabricate some of this, or something sufficient enough. I'm going to see if I can do it. I'm not sure I can do it. I'm going to try. And if I can, that's going to make this a heck of a lot cheaper, because I could probably do it for, a couple $100 or less. And I might even look into buying these components from an existing transmission, maybe some type of package, if I can find it cheap enough, and if I think it can handle the torque load, which it probably could, but I'll have to do some research. So that's where I think I'm headed, because one of these, or two of these I should say, in a sleeve mounted to sprockets on each end is going to be a heck of a lot cheaper than one of those. So when the weight is all the way down on this gravity-driven generator, when the weight's all the way down on the floor, on the ground, and nothing's moving through the whole entire generator, this sleeve will be able to slide on and off manually. So that's what I'll be doing. I'll manually be sliding it to engage it and manually sliding it back to disengage it. And yeah, I may have to wind up the weight a little bit with the boat winch just a little bit to get this synchronized, but I'm going to make sure the synchronizers are far enough apart, meaning the teeth on the synchronizing hub, they're not going to be as many teeth as you see here. I'm going to have fewer than those, maybe 8, maybe 10 or 12 total all the way around. So there'll be larger gaps between these teeth, and that'll be easy to synchronize them when the weight is, all the way to the ground. But I don't foresee that being a problem. If I have to move the weight a little bit with the boat winch, wind it up an inch or two to get this hole to synchronize, shouldn't be a problem. So I just want to tune you guys into what I'm doing because I said before in the previous videos that I want to keep you guys informed about where I'm headed, and I think this is something I'm going to delve into a little bit and see if it's possible for me to do this and keep the budget within reason, because that right there just I would love to have one of these. This would be great because this is this is really nice, the way to go, just not affordable. Alright guys, thanks for watching. Please subscribe to my YouTube channel because it makes a difference. Thumbs up on my YouTube channel, I really appreciate it. I'm looking forward to continue with this project. I'm starting to get back into this, and once I get done with my research part, it's going to be back to either making components and integrating components and getting this puppy up and running. Alright guys, thanks a lot. Thanks for watching. Talk to you soon.